Hello class, what we're going to talk about today are even and odd functions. All right? I thought only numbers can be even or odd, right? Well, no, we can have functions can be even and odd as well. It's not just for numbers. Now, with an even function, what that is, that's where if you plug in negative x, you have f of negative x, it's going to equal the exact same thing as if you have f of positive x. All right? So if you take negative x and you plug it into your original function and simplify, it's going to come out looking just like your original function. Also, what happens here is if you plug in some value for x, let's say like 5, and you get an answer of 10, and then you go and you plug in negative 5, you still get an answer of 10. All right? And that works for every single value of x. That's an even function. And the graph of this is going to be symmetric about the y-axis. So you could take this and fold it over and get the same thing. So you notice here we have x equals y, and here you have negative x equals y. So it's the same thing. That works all the way around. Now, an odd function is a little bit different. With an odd function, when you plug in negative x, you end up with a value of negative f of x. So, for example, in our other thing, if I plugged in 5 and I got if I plug in 5 and I get 10 for every answer, then if I plug in negative 5, I'll get an answer of negative 10. All right? Or if I plug in 2 into the original function and I get an answer of, say, negative 7, then if it's odd and I plug in negative 2, then I'd get an answer of positive 7. So it's symmetrical like that. And that's an odd function. And these will graph symmetrical about the origin. This is not a line of symmetry. What this is rotational symmetry. So I can take this and I can rotate it, and now it looks exactly the same as it did before I rotated it. Okay, so it's a 180-degree rotation around the origin on the graph. Right. So let's take a look at these. Here we go. We want to determine whether each function is odd, even, or neither, because yes, functions can be neither odd nor even, just like you can have numbers that aren't odd or even. These be your fractions and decimals and things. So like 2/3, is that odd or is it even? Well, it's not either one. Same thing can happen with functions. All right, so let's take a look at this. Let's take a look at A. So we have f of x equals x cubed minus 7x. All right. Well, we're going to plug in negative x for x. So negative x, so I have negative x cubed minus 7 times negative x. Well, a negative cubed is still negative, so I've got negative x cubed plus, and then a negative times negative, so plus 7x. All right. If you notice, see, is it the exact same as the original? No, it's not the same. Did the signs change? Yes, all of the signs changed. Positive became negative, negative became positive. And so what this means is this is an odd function. All right. And if we wanted to look at the graph, there's the graph. You see this is symmetrical about the origin. I could take this and spin it around. It would look exactly the same. So this is odd. All right, so on B, first thing we're going to do, we're going to plug in a negative x for all of these x's. And so we have negative x to the 4th, negative x squared, and then minus 1. Well, a negative raised to the even power is going to come out positive. So this is positive x to the 4th. Negative raised to an even power again, so it's going to be positive, so positive x squared, and then the minus 1. Does this exactly match the original? Yes, it does. And since this exactly matches the original, and let's see, we'll pull up the graph. It's right there. There it is. You see this is symmetrical about the y-axis. This is even. Last one down here, x cubed plus 2. We're going to plug in a negative x there. And so negative x cubed, well, a negative raised to an odd power is going to be negative. So we got negative x cubed plus 2. There it is. Is it exactly the same as the original? Nope, that one's got a negative. Did all of the signs change? No, only the one for the x cubed changed. The 2 is still positive. So it didn't change all the signs like an odd. It didn't stay completely the same like an even. And if we look at the graph, could I fold this over the y-axis? No. Could I rotate it around the origin? No. And so, let's see, I can actually do that quick. If I rotate it around the origin, that doesn't look the same, because now my y-intercept is at negative 2 instead of positive 2, right? Not the same thing. So this is not even, this is not odd, this is neither one. Okay. So let's take a look at these three. In fact, I would like you to work these three problems out. All I want you to do is to tell me, are they odd, are they even, are they neither one? All right? Pause the video, work those out, and then come back. Okay, so let's see how you did. Boom, here's our answers. All right, so number 5, you should have come up with even. You can do that looking at the graph, or if you plug in a negative x, it comes out looking exactly the same. Over here, the graph is not going to flip over. It's not going to be rotational. So this, this is neither. Also, if you plug in a negative x, you'll see this sign stayed the same, but here my negative became positive. And so it's not exactly the same. It's not completely flipped on your signs, and so this is neither. Number 7, we see our signs changed. All of them. There's only one, but it changed. And we see this. I could take this and spin it around. It's exactly the same. So this is odd. And so that's odd, even, and neither. Now, there is one other thing that's a little bit of a shortcut with this. If you look at your equation, and you look at the variables in the function, if every single exponent in the function is even, you'll have an even function. If every single exponent in the function is odd, you'll have an odd function. Now, you'll notice on number 6, I have a 4, which is even, and a 3, which is not even. And so since they're not both even and they're not both odd, then it's neither one. Also, if you come back right here, I have x squared, and here the exponent on my variable is actually 0, which is an even number. And so this is even. But if we look at this one, the only exponent I see is 3. Remember, there is an x to the 0 right here, which is even. So I've got an odd and an even, and so this is neither one. All right? Here you have an exponent of 1, so it's odd and odd, so it's all odd. Here 4, 2, and this would be x to the 0, so 4, 2, 0, which is all even. All right? So that's another little way you can do this without having to graph it, without having to put in the negative x. But this right here, we plug in the negative x. That is the preferred, most technically correct way of doing it. So, anyways, that's odd, even functions, and I hope that helps you. I'll see you next time.